They're in listen only mode.
Excellent.
Dylan is there.
Hey, good morning, everybody. My name is Zach Sherman, and there's my alarm saying that we're going to go. All right. I just wanted to welcome everybody here. With millions of people on lockdown, we appreciate you coming by. I want to apologize firsthand that this was supposed to be given yesterday at a little bit later time in the afternoon, but our friendly host GoToMeeting apparently had some severe network traffic and maybe crashed a little bit. And we encourage you to focus on how we can help and how to make you better with this at this particular time by one, keeping your network running smoothly with a small or smaller networking team, and mostly by improving your operational efficiency and increased connectivity range while using a number of different products, including our wireless ones. Today's webinar, we're going to go over several of those things. Just a couple of action items before we get into it. First, you've got myself, Zach Sherman, network sales engineer for EtherWAN, doing most of the presentation, and my senior product manager, marketing manager, Brian Tudor. Brian, introduce yourself if you'd like.
Hello, Brian Tudor here. I'm also acting product manager for all the wireless stuff, so I'll be backing up Zach on all these questions. I'll be answering all the questions you have. So,
yeah. Excellent. Thank you, Brian. Please, if you have questions during the middle, send them in, type them into the thing, raise your hand, whatever. We'll be monitoring it, but there is going to be a question and answer section at the end of the presentation. That said, it's a chance to win big. We are giving away several random Amazon gift cards for completed surveys at the end of the presentation. They come out right away. They're just SurveyMonkey, a couple of quick questions. We appreciate the feedback. One, it helps us get better and deliver more of the content that you're actually looking for, not just what we'd like to preach to you. All right. Today's agenda in particular, we're going to cover wireless technology, a quick brief overview, and an update. Specifically, there's a lot of what we call alphabet soup, and I'll get into that in a minute. Then we are going to go over what bandwidth issues might be happening to you and why they might be happening. It's kind of complex. We get a lot of complaints or a lot of concerns that what's my real bandwidth going to be, and we'll get into that. How can EtherWAN help with those particular applications? We'll go over a little bit of our deployments, and then we'll talk about selecting an appropriate product for what you're trying to do. Now, we're obviously going to talk about our products in that, but we want you to know that there are many options out there. A little bit of housekeeping, who EtherWAN happens to be. EtherWAN was started by a group of JPL engineers that worked for NASA. They needed switches and media converters that worked within the extended temperature range. We've been in business for over 20 years. We are backed by a parent company called Phoenix Contact, who is a monster. They're a $6 billion company, if I remember right, or $2 billion company. And they are based out of Germany, and the US based is out of Harrisburg, Pennsylvania. We have a lifetime warranty on all of our hardened products. We have free US-based technical support, free training, such as what we're here, kind enough to join us on today. And we do our own manufacturing. So we have our control over that process. As we get into times like this, it's important to know that we have control of that. We are still fully functional, and everything's going out. We are TAA compliant. Everything is built in TAA compliant countries, essentially not China in this case. Proprietary patented technology. We do our own product development. We do own our own stack. So we have a little bit of capability beyond what you'd call the standard-based systems. Why would anybody choose EtherWAN? Well, we have a number of different full PoE capabilities. This is related to what we advertise is actually what we deliver. You see a lot of our competitors have trouble meeting what they're saying, or they're trying to hide it. We'd rather publish the actual truth. We have managed and unmanaged solutions. Managed like solutions for control of your network to limit the amount of the mean time to repair, to how fast can you fix something and get back up. The outdoor and indoor solutions. Today we're only going to be talking about outdoor rated products, but we do offer a full range of office graded solutions as well as the hardened. And the comprehensive support. This is probably our biggest point. We really want to be there for you. pre-sales, post-sales, and afterwards. So if there's ever any sort of problem, whereas some of our competitors seem to disappear, especially if there is a problem. So jumping right in, what is Wi-Fi? Wi-Fi is a standard written by IEEE. It's 802.11, right? So there's a lot of littles. You see in the upper right-hand corner, there's some alphabet soup here. You got A, B, G, N, and AC. The difference is really speed and range, and we'll get into that in the next slide. The two that you need to know are N and AC. They are the ones that are current. Everything else is old technology, outdated. You're not going to be able to go out and buy that anymore. But in order to support existing infrastructure, the AC and N are all backwards compatible. So when we list AC, it also does A, B, G, and N, if that makes sense. As I said there, the speed range is from 11 meg to 5 gig. Here's a little bit of a breakdown. So you see on the right, you get the lovely chart, which will test your eyes, just like it does for me. It is the widely used computer networking standard in the world. In industrial applications, Wi-Fi provides high-speed connectivity when it's not possible or cost-effective to lay fiber optic cable or to put in copper cable if the particular infrastructure can support it. So you see a lot of different information on there: max data rate, indoor range. As EtherWAN gets into this, we do mostly outdoor, but you're talking about the specific antenna, not necessarily the individual product itself. For example, here happens to be a hardware spec of one of our products. You can see the operating temperature. Everything we do here is going to be -40 to 75 or very close. Ambient, relative humidity, wind load. Again, we're trying to make all of this very visible so people deploy it, and in a hurricane and it gets blown down. Well, now that we've potentially at least mitigated some of that. Wireless transmission rate, the 5 gigahertz range, so 802.11a, 802.11n, and 802.11ac are all listed there. And then you see the Ethernet data rate for LAN wireless, LAN to wireless, excuse me, for 802.11c. So all that's great. If you look back, 6.9 gigabits. Okay, well, what are you really going to get? Well, there's a lot of things that go into why you're not getting that, so to speak. We get questions quite often on, if I deploy this, what kind of bandwidth can I expect? Well, that's really hard to determine. The reason is something that we call the Fresnel zone. Now, I'm not going to go into this particularly deep because the equations get painful and you'll see them in a couple of slides. But basically, what it's telling you is that the best area for that transmission, where you want maximum amount of bandwidth and throughput and continuous connectivity, requires a certain calculation. So when I'm at my own house working on Wi-Fi, as I am currently, and I'm sure most of you are, why doesn't it work in one room and not in another? Why did they say don't put it underneath a metal plate, don't put it against the wall, those kind of things? Well, this is the reason. The Fresnel zone determines your ability to get the signal. So some obstructions in the Fresnel zone can be tolerated. Obstruction is allowable up to 40%. So the tree, for example, but typical recommendation for best connectivity and reliability is going to be 20% or less. Some of this comes from a best effort service, right? So Wi-Fi is giving you a possibility. As many people know, if you're working from a passive optical network, not a physical wireless network or a virtual wireless network, there is a shared bandwidth. Ethernet is a best effort technology, so you don't get exactly what it's giving you, you get the best thing it can do. All right. So just so you know, this is the calculation. Nobody has to learn this slide. This is just so that you know that people are doing it for you. My good friend Brian pointed out that there is a Fresnel calculator available online if you just Google Fresnel calculator. So just be aware that this doesn't have to be done by you, but keep in mind that the higher up we go, or the farther we go, and like as in this picture, the higher up you have to go. All right. This is a good example of that. I'm sorry, was there something else? Did I miss? Okay. All right. So here, for example, we did a couple of brief calculations based on the frequency and the and the distance you're actually trying to go. You can see that as you go farther, you have to go higher, right? Because the R needs to be higher. All right, so wireless applications. The rest of this presentation is going to be related to actual deployments, things that you need to, you may want to be aware of. For example, we can do redundant ring technology with our wireless products. This is a good example of a transportation example. This was a rail where they wanted to be able to have a failover in the event that there was something that went wrong. As far as the switch is concerned, the switch that's generating the RSCP bridge path doesn't recognize that it's connected to a wireless product. It doesn't see the next step, so it's just treated like a regular wire. So that kind of, for me mentally, that's what I wrap my head around. The wireless is just functioning like a physical wire. It's just not wired. So if a wireless link goes down, the switch will automatically go through and restore the different path. So again, this is done even through wireless. So you still get potential redundancy rather than what I'd call traditional. Wireless is our absolute worst backup. That's not what we want here. This application is a guardhouse with remote locations for a bridge. So here we're trying to make sure that all of the signals cover each other. Brian, would you got anything you want to say about this particular one?
Yeah, so this was an actual application, and so they really wanted to have this guard shack, and they had these cameras, and they needed to get back to the guard shack. Depending on which product they used of ours, it has a 17-degree angle on the wireless on the panel antennas. So they were able to point them directly at the guard shacks. The guard shacks are those red arrows, and the cameras are the black ones. And so they were able to get, full bandwidth on the cameras. The red ones have to be access points, and the black ones were just bridges, which are point to point. That's about it.
All right, thank you. Yeah, and the idea being we can overlap them. They're not strict line of sight, right? Because if you look at the Fresnel zone, that's it's a oval, not a straight line. Here we depict going around a specific obstacle. Now, in this case, we've got a couple of different products here, but this works for just about all of our wireless products because they're point to point. This is strictly bridges. Now, wireless bridges, as well as actual physical car driving over bridge or bridge for rail traffic, whatever it happens to be. Here we're talking about how would you do point to point when you actually have an individual obstacle. If, for example, a tree is in the way. We'll go over that in another slide, but know that this is easily doable. You can also do it with an access point. So terminology-wise, I personally have trouble with an access point because I mentally think of the little cheap box that's in my house. But basically what it's saying is that it can take multiple different inputs and outputs at the same time versus the bridge being one in, one out. Right? That's really what we're looking at. So it is functioning like an access point, but for 5 miles, not for 335 meters. Just be aware.
Yeah, and one of the things I want to point out on that, and the reason that I created both these slides is, go back to the previous one, Zach.
Absolutely.
These are this product is a bridge with a panel antenna, and it'll do 20 miles. So if you have to go around an obstacle and you have long distances, you're better off using a bridge with a switch bridging the two on the inside. Now go to the next slide. This is the, go to the next slide. Yeah, this is an access point. Our access point with an omnidirectional, we've actually tested that at 5 miles. So it does pretty far for a omnidirectional, which is what you have in your house, is omnidirectional, but they don't do 5 miles because they're not as the same kind of antenna. So if you've got, your throughput doesn't need to be, 866 megabits, and it still does a pretty good, 50 megabit at 5 miles, and you only have to go 1 mile or half mile. This is the way to go because you have more options.
Absolutely. Thank you, Brian.
Mm-hmm.
So this is a point to multi-point example. Brian mentioned the 17-degree angle that we're broadcasting at for optimal connectivity. Now that there are some exceptions to that, and there's the Fresnel zone's got some bubbles, but we're not going to get into that today. Mainly, so there's an access point version of our 75,000 series 13-13, which means it can take in multiple different signals. Or as we showed on the previous slide, you could use an 08 version to do roughly the same thing. But for the further distance opportunities, you're going to want to go with the 1304 version. Okay. Now there is wireless. Wireless. I just blanked on it. WDS, Brian, give it to me.
Oh, WDS is it's kind of like mesh, but it's a little bit better because our product supports WDS static mode and WDS dynamic. And static is recommended. What you do is you go into each unit and say, you're going to connect to this unit. And you point to that unit, and then that unit points back. And you can then take your same units that you were using before, but now you've got an obstacle between the point to point. Using WDS, you can go around those obstacles by pointing one unit to another, as you can see in that diagram below. So this is something that not that many people know about, but if you, in the actual case, this was actually a grain processing plant that is a customer of ours, and they could use point to point. But I wanted to show if there was something like a water tower in the middle, you can go around it using WDS and the same units you've already got.
Yeah, thank you, Brian. I'm sorry. WDS to me stands for wireless directional switching. So that there we go. So that's probably what we're talking about. All right. So how do you select an appropriate product for a specific example? First, all of our EtherWAN's products are IP67 rated. They are protected against hard rain. I'm not sure how much you can sync them. They probably have a depth rating that I don't know IP67's numbers that well. The -40 to +40 degrees operating temperature. I know it's in Fahrenheit there. That's -40 Fahrenheit to 167, but in centigrade, that's -40 to +75 centigrade, I think. Wind rated up to 125 miles an hour. Again, they do kind of look like sails. We'll show the size. So the wind rating is important to me. Doesn't mean a whole lot, but when it's deployed outside, it's obviously going to mean something. The first product that we offer is an EasyLink 300. It's pre-configured unmanaged bridge. So if we went, I'll go back to the other slide. If you're going back to bridges, this is how a bridge would have to work. It's point to point, and you'd need to have line of sight. Okay. All right. So there are 2 of them in every kit. Everything's included, including the rack mount gear, including the PoE injector, including all of the connectivity that you need. The best part about these is that there is absolutely no configuration necessary. Each kit contains everything that you need. They're already paired together, and they are ready to deploy. And I've got a video here, and I know the audio is not going to come through, so I will nail it. Excuse me, I will narrate it while Dylan does his production here. So Dylan's going to show us how to do both of the 2 wireless bridges, how to connect them. You see them mounted already. The first step, plug in one of them. The second step, you plug in the other. And that is the entire setup needed. Oh, there we go. All right. So for those of you who are wondering, why did we make that? The idea is we want everybody to be able to deploy it. It just go very, very quickly, right? The lowest out-of-pocket cost, right? So it's going to be very inexpensive. It's just plug and point, right? The lights come on, it's up and running. It's a small form factor, and it connects to remote locations up to about 2 miles. As an engineer, I'd say 1, but I think we tested it fully to 2. So there we go. There are some limits to it. Basically, if you use a pre-configured bridge, you really don't have any control over the connections. It's auto gonna select the channels that it uses. It's only gonna support up to 2 mile connections. It only does point to point, and it doesn't support network monitoring. So you're not gonna get the RMON stats. You're not gonna get the statistics that you might be able to get from our more advanced products, which leads us to, oh, Brian, I'm sorry. I did it without the without the animation. All right. So just so you know, those are the limitations. And it is 300 megabits maximum speed as well. Now, to solve those particular problems, we have the E-Wave series. Here, something is fully configurable. It's a managed access point or a bridge. It has enterprise level features, which we're going to get into here in a second. First, it does dual band, so it's single and dual band. So it does, depends on the model number. You get up to 866 megabits per second on the dual band. The powered by AT or BT capabilities, and it is unidirectional and omnidirectional versions. So unidirectional being point to point, omnidirectional creating a circle or a globe, if you will, and accepting more like a traditional access point. Nice part is it's up to 20 miles. This slide is up here because if you get up to 20 miles, it better be at the top of the mountain. Because if you remember the Fresnel zone, you're going to get significant interference from anything that's low, right? So if there's stuff in the ground, heck, if planes are flying between them, just be aware that the farther you go, the higher up you must go in order to maintain excellent connection speeds and throughput. When we talk about enterprise level features, now these are going to do full VPN, VLAN support, layer 3 routing like OSPF and RIP protocols, radius server authentication, firewalls, testing tools, and and statistics that give you throughput and all those wonderful things. From a physical size standpoint, you can see that the EasyLink is significantly smaller than our E-Wave series container. Now that makes a lot of that is good, but it also means that there's a lot less stuff in it, right? So that hence why it doesn't do those things. Finally, we're going to get into some of our actual deployments. These are individual examples of how you can deploy these particular products. Brian, interrupt me if you have anything you'd like to say that I'm missing on these, because I know you are personally involved. Here you can see, okay, go ahead.
So this is the actual, this is the one in Cleveland. This is their RTA, the transit authority there, regional transit authority. And this is the one where they said that after they installed everything, I flew out there and they said, by the way, this is going to be controlling some mission critical stuff. And that's when I said, well, you need to use this RSTP and redundancy. And that's when they bought another 14 units was total, then they added them in and made this link, this ring basically. So this is, a wireless is not typically known for, being mission critical, single point of failure type is a problem with wireless. And so people don't really think of wireless as being reliable, but I just talked to the guys that did this and they are at 99.91% uptime. So it's working great for them. If they had any problems, they don't even know, because when RSTP works, it takes less than 5 seconds to switch over, and they don't even notice it in their audio or their video. So they're having no problems with it.
Excellent, thank you. Here you can see the top of a building to a pole. Which, Brian, do you know what they're hooking up at the pole? Well,
I know that in some cases, in this one I'm not sure. The one on this pole over here is a power substation. So I actually visited this site, and inside that door, there's all these huge, giant equipment with power controls and stuff like that. So they're monitoring the equipment.
All right. Here's just a train station example, point to point. All right. So that sums up our presentation for today. If you're looking for more technical information, if you're looking for more courses available, if you're looking for continuing education credits, be it IMSA for traffic folks or BIXI continuing education credits for RCDDs, please visit our EtherWAN Academy site. That's academy.etherwan.com. Everything's there. Now here, you go at your own speed. You're going to get all the information. You're going to be able to deep dive a little bit further than we are here today. And by all means, email me directly if you'd like, and we can go into a further discussion on if you want to talk about 802.11n's, for example, things that would make a lot of people go to sleep. So if you need that stuff, please hit us up. Now, Brian, you're in charge of question and answer, my friend. Do we have anything, or is anything
Yeah,
coming up?
a couple things. First, I'm gonna just quickly go over the differences between, because we talked about the EasyLink a little bit. So I'm just gonna go over that a little bit so that you understand the differences. The EasyLink is a very competitively priced kit where you get 2 units and they're pre-configured. You don't do anything but plug them in and point them, and they do everything you need. That's really designed around up to 2 miles. It'll go up to 300 megabits. We've tested it. It's a 2.4 gigahertz, so it does better through going through objects than 5 gigahertz. The other product line we have is the E-Wave, and that is basically a series of bridges and access points that has full control, fully managed, full enterprise router, OSPF routing, firewalls, everything like that. But it does require configuration, so you don't just put them up and point them. So it really depends on what you need. Okay, so I just wanted to go over those. So I have some questions I'm going to answer. Some of these I answered already directly to the people that were talking, but since more are coming in now, I'm going to go through the ones I've already answered verbally, and then I'm going to answer the ones that came through. So one said, would your bandwidth and throughput be affected by the use of an access point? The answer is no to the access point. It's not different than a bridge. The biggest difference between an access point and a bridge is point-to-point only, and an access point is point-to-multipoint. What really affects the throughput is the actual antenna. So some of our access points have omnidirectionals, and some of them have panels, and our bridges all have panel antennas. The panel antennas do 20-mile distance, doesn't matter whether it's an access point or a bridge. It's really the same operating system, it's just a different configuration, and the bridges only support point-to-point, not point-to-multipoint. So the distance is really not related to the access point bridge, it's related to the antenna. So, but in some cases, if you're doing less than a mile, you're gonna get very good throughput with an omnidirectional also. Okay, so the next question. If you have access or points A through F and you don't have direct line of sight, but all the points between A to F, for example, is a bridge still needed? That depends in your topology. Yes, in your topology, a bridge is typically what you would use, but if you want to do something like WDS and you need a unit to connect to more than one to go around an object, you would use an access point. So if you want to go around an object, you can point 2 bridges to one edge of that obstacle and then another bridge to another, or you can use an access point. And so in the example that we showed in the grain processing plant, you went around an obstacle by pointing your access points in different directions to go around that obstacle. So points, line of sight is exactly what it is. If you can see it, you can get to it. Of course, that doesn't take into account the Fresnel zone. So that's something you have to keep in mind also. I have tested, for example, a unit going through a Fresnel zone where over 45% was covered, and I still got 200 megabit throughput on an EasyLink, which is a 300 megabit. So it depends on the distance. There's a lot of things that come into play there. Okay, let's see here. Next question. With the EasyLink 300, is there a minimum distance apart that they need to be mounted? Sometimes we have very close buildings in a housing authority application. The answer is yes. 100, I have tested this personally. 100 feet is the minimum distance recommended. Now I have connected at 5 feet. Just your throughput goes down. So at 100 feet, as I test, I went 25 feet. I went 50, 75. When I hit 100, it was faster throughput than it was at 75. And then as I went further out, it started going down. And of course, by that point, I wasn't, in my testing, I wasn't high enough to take into account the Fresnel zone. So really 100 feet is the minimum recommended, but you can go lower than that, of course. Yes, we can send this presentation out, someone asked. Let's see here. Yeah, there's someone asked a question about getting help with configuring applications. Yes, we do help. If you have an application and you need help with it, contact us and we can help out. We've got a lot of experience under our belts with topologies and getting around things in different modes. A lot of people talk about mesh. We don't typically recommend mesh, and mesh is fine. Mesh is something that you use when you don't really care that much about latency or throughput. But we typically recommend something that's similar, which is WDS. But if you need help and you have a topology, contact us and we can help you do Someone asked how our product compares to fluid mesh. You know, we're talking about 802.11n and 802.11 AC and antennas. That's what you're talking about. So when you talk about comparing to another company, you're talking about, you know, so many different things. Our antennas do 20 miles. Does fluid meshes do 20 miles? They have different models. You know, if you look at price and price alone, then we're more competitive than fluid meshes. If you're talking about functionality, they're identical. They may have, fluid mesh has a very specific application for rail. If you're on a moving object that's going very fast, then they have some special technology for that. That's very, very specific to wayside and rail and high fast moving objects, which we are not designed necessarily around. So they may have some specific functionality, but it's not, that's why their price is high. So you really got to take it with what your application is. And so you know, fluid mesh and any of the other competitors, they have very specific functionality. Now I can talk about other competitors too. For example, Ubiquiti. Ubiquiti is very, very cheap, but what the problem with Ubiquiti is you don't get help. If you want to call them directly, they're not going to help you, because I know from experience that they're going to point you to your distributors, which in some cases might be fine. But with our products, we help you. So that's very important to some people, because it's one throat to choke. If you buy all your products from us and get all your help from us, everything is taken care of by us. And that includes, we're going to be including accessories. We're going to have cables you can get from us. We're going to get aligned. We haven't got them yet, but we're getting alignment tools that we're working on getting to help you align these units using this really cool telescopes that mount onto the units. So there's a lot of stuff that you can get. We're the one-stop shop, one throat to choke. If you have any problems, we're not going to point to somebody else. We're going to take care of it for you. Okay. Do we have management software that will show all of the radios with their link speeds and quality? I currently have 250 radios of another brand that I can see at a glance and their status on the map or a grid. So no, we don't have that yet. It is something we're looking at. We have an application called eView that's going to have certain functionality, which is going to be assigning IPs and doing some monitoring. Of course, we do support SNMP, so you can monitor the devices with SNMP, and they do have a web browser page to connect to and upload firmware and stuff like that. So that is a very you know, expensive proposition to be able to have that stuff, and so you know, you're going to get what you pay for. So if you're talking about some of the companies out there that have these specific applications, those are pretty cool applications,